Bismillahirrahmanirrahim. Continuing to our subassembly composer. Today video is on sand pill around the cross section. As you can see, there is rounding, side slope, a curve here, and slope. If you open this tab of the subassemblies and shoulder tab, you will not found this kind of subassembly. There are no step, they are perpendicular, you can see. Sometime in our cross section, if you check all the shoulder subassembly, there is no such type of subassembly available which have slope and outside edge of the layer any subgrade aggregate. So at that time we need to make a different subassembly with the slope and outside edge in the subassembly composer. So this is today video about this compacted pill subassembly. We will make this today. First of all, we will start from the point which is connection point. So from here it will connect to the main assembly, and then we will draw these sides slope and the other side. So let's start. First of all, I will create a point. I will rename it as a connection point. The distance from origin, it's 0 0 because it's starting from that point. Create another point which is, I will take because this only practice video, so I will take just supposition as suppose my length is like this. Suppose this is 0.5% and the slope is normal slope for the road is 2%, so I will write 2 here. Again there is a rounding, but from the start I will take it as a straight length. Then at the end we will add a curve to it. Okay, so for this point I will write arc point, arc center point. Okay, this also a delta x and delta y. The point geometry I put in just supposition, so you should put in from your typical section. The value of y is minus because it will come downside. So this point code, suppose this is my end of rounding. You can type any type of code. Delta x and y, suppose this is 0.5 meter and the y elevation is going down. Suppose I will take 9 cm. So at the end I will create curve on this point. Okay, now there is a length which have x value 5.23 and slope 6/1. I will adjust the arrow. Okay, so this point code, suppose I will write slope from here, slope and delta x 6/1. and the 5.23 is the length. Now from this side, this side, I will give the first step, which is including a aggregate asphalt varying course and base course connecting to aggregate. So let's zoom this portion. Let's try and delta x slope and delta y. If we could create like this, if you can see the slope 1:1 and the delta y, it's need always the positive value. So as you can see, when I put the minus value, it's disappearing. If I add minus value to slope also, if I reverse the direction, it's not working. If I put minus value with the slope, it's also disappearing. So better you try and delta x and delta y. As you can see, it's only need a positive value. So I will try and delta x and delta y. Angle and distance also, you will calculate angle and distance from the typical, but better put delta x and delta y. My x value is, as you can see, the thickness of both varying and both base course, 5 cm and 20 cm. So it's mean 25 on this x side and 25 on the y side. So 125 on the x-axis and minus 25 cm on the y-axis. As you can see, it's clear. The link created again for this outside edge, which is sometime 0.10, sometime 0.20. Again delta x and y, you can put according to your cross section. Typical section, you will follow your typical section. So if it is 10, you must put 10. If it is 20, you must put 20, and the y value is 0. So this is the first step for the asphalt. Then for the aggregate, again I will create the same process. The same process, the thickness of the layer and the slope 1:1. So what is the thickness? The same distance will be on the x. Again for the outside edge, for the subgrade layer, again for the subgrade, I will write, suppose the thickness of subgrade is 30 cm. Normally it's 30 cm, so I will write 30, and also for the y-axis is minus 30. Now you can see the steps are completed. So I will put a simple link between point number 10 and 5 to connect these both sides. So the simple link between point number 10 and 5. So 5 to 10 is the link between these 2 points, and the shape almost completed. Now we will put here the curve. You should put the curve at the end. If you will put the curve and made the connection point between these point will not happen, and there will be a problem inside. So better at the end you put connection. This connection, sorry, this curve. So I will create curve for 3 points. As you can see, 3 points. I will remove the link 1, 2 and 3. I don't need, because I already put a new link in the shape of curve. So only curve I will. Now as you can see, there is curve. To make it smoother, I will put point number 4 little bit. As you can see, it's not looking smooth, so a little adjust a point. Now it's looking good. So this is the shape of the sand fill subassembly. Now the connection point is here. Already I rename the assembly the points. So let's put some code. Point number 1. If no link, there is no need to put the code. For the point number 2, point number 2 is write something like shoulder top. I will copy this, and then it's the slope. No problem for the top side, but for the bottom side, always remember creating the bottom link. You must put the datum code. So when you create cross section, the datum surface will catch this line. For the this portion, I will create some output parameter slope. I will put slope as this 6:1. So I will put here 6. We will copy this code and put here in the slope section with the minus sign. And now I will check if it is working or not. I will change the slope 10:1, and yes, it's working. So again, return into its original slope 6:1. Put code for each thing you need to. Suppose something is varies in dimension, so you must put the parameter and put parameter. So in Civil 3D, inside Civil 3D you can change them. Okay, this the number of arc corners inside this curve, so you can increase to smooth curve smooth. Okay, I will write this as a name of rounding. For the datum length, already I put datum code, and this is the bottom, but as we put link between 5 and 10, so we don't need this input parameter for that one. I will change this to suppose I want sometime in our cross section the varying course is varies 5 centi 8 centi, so for both the varying asphalt varying and base course I will put the input parameter. Suppose the you must not put space between the name. If you will put, it's not accepting. So write thickness asphalt varying course thickness with this, and asphalt varying course. Suppose this the 1:1 is slope, so we will put slope here. No need to put the slope here, just double mean the decimal, the digit with the including the decimal. So I will put this code inside my point geometry properties. Okay, now the same process you must follow for all the lengths. I change this one. Let's see, yes, it's working. Before taking it to Civil 3D, you must check this the dimension, make changes and check see if it is working or not. Okay, the other dimension outer edge for the different layer I will put. So suppose sometime it's 20, sometime it's 10, you can select from here or from here. So put this also and then check if it is working. Yes, it's moving there according to the value. So also put here the shortcut. This one already I created. So now this completed the shape it code completed. Now let's put the target parameter for the side slope. You can put from daylight from the Civil 3D. We have now for the super elevation for this side, put super elevation for this length below, so it will follow the super elevation as per super elevation the main road, it will follow that the same one. So for this creates super elevation in the type, and in the remain automatically super elevation appear. From here you can select the side, which side is better, you put none. Right outside lane, if you rename it, you should rename right side outer lane, because it's outer lane super elevation, this lane name is super elevation. And from here better you put none, and the civil 3D you can then select for this one, which is this one. So the super elevation from here you can adjust. Okay, for the super elevation axis of rotation you must put here unsupported, and then supported should be put in the inside the civil 3D. Going there you can choose support. So with this, if I want to adjust the super elevation, I will apply AOR here, and you put, if you put supported, you can see it will create a problem. So better you put unsupported here. In the super elevation menu here, the no you cannot put here the values. You must put the value. If you want to put in the super elevation here in the super elevation tab, what value you are carrying, so put from here. Okay, now we will save this assembly, sub-assembly to, will rename this one, and then we can import it as in civil 3D. Suppose this is my sand pill sub-assembly. Okay, so and as you can see there is a problem inside this when I put the supported and support value. So better you put enter Control Z to. So now the shape is complete. So for the here put always unsupported from here. Okay, now save it again, this one. Okay, here I will open the rank in which we have created the section, so we can check it here it is working or not. Okay, before taking it to Civil 3D, we must put a shape to calculate the volume of the sand fill. So I will select a shape for that one. Okay, it's automatically select the length, and I will rename this as a shape code as a sand fill. Now again I will save this to sand fill rename, and okay, replace the old one, and then okay. Now let's take it in the Civil 3D. I will create a new assembly for this one, or better we can try it here in this section. We can see if it is working or not. So let's first import it here in my custom subassembly tab. Right click here and then import subassembly, sand fill, select, and then okay. Okay, delete this one. And again I will insert this to here, select the subassembly. Okay, now shift the sides daylight slope, and then again go to the, now as you can see it's connected to our assembly, main assembly. Go to your corridor, select the properties, and then set all target, select the target, and then apply rebuild. Okay, and now check the cross section. Yes, it's connected to the working and is working properly. As you can see, check another cross section. I did not create a surface, so the surface from the old cross section. So as you can see, it's connecting. If I put elevation, it will work. So as you can see, the daylight also connected with this subassembly. Here also the same. So this was today video about the samples subassembly. Hopefully you will practice on it. Okay, thank you.